Hello and welcome. Let us discuss today on the mitigation aspect of energy. Today is the 28th lecture, that is the third lecture of 6th week. So, we are going to cover these concepts. So, first is in terms of energy, what are the various alternate energy sources, and then the various systems, or you say the multiple systems that facilitate that leads to this alternate energy involvement. And second is, the third is the cost effectiveness. It has to be a cheaper, it is definitely greener, but it has to be a cheaper technology, so that the adaptation by the people, by the society is faster and in a larger scale. So, dimensions, as far as the dimensions and indicators of implementing mitigation options in low carbon energy systems. We will talk about this, what are the various dimensions and indicators of implementing these mitigation options as far as the alternate energy is concerned, and with respect to low carbon energy systems. So, all this, most of the alternate energy are greener, and that is why they are also, they do fall under the low carbon energy systems. What are the various factors that enable and inhibit? So, there are factors that will enable or facilitate the deployment or mitigation options in terms of the alternate energy. There are factors that will also inhibit. So, that means we have to work on addressing the inhibition, that are the bottlenecks. So, we have to address the bottlenecks or the inhibitions that are on the path of, or in the path of deploying the mitigation options as far as the energy system or the alternate energy system is concerned. The fourth is relevance of the key climatic impact drivers for major categories of activities in the energy sector. So, what do we mean by this? That what are the relevance as far as all these various forms of alternate energy is concerned with respect to the climate impact, because here we are talking in terms of the mitigation as far as the climate change is concerned. So, what are the various alternate energy sources in offer, and how is the relevance as far as mitigating the climate change? Then what is that we need to achieve net zero emission as far as this energy system or energy sector is concerned. This particular bar diagram talks about the global solar and wind electricity installation capabilities. So, we can see the blue bar, the blue histogram talks about or represents the wind energy, whereas the orange one indicates about the solar energy. So, what is the potential as far as when we move from 2015 to 2019, and on the y axis is shown the cumulative installation capacity in terms of gigawatts of energy generation, whereas on the y prime axis it is mentioned the share in total electricity generation. So, if you see in terms of the share by 2019, the share you can say 8 plus 8 16%, more than 16% share was coming from solar and wind as far as the electricity installation capability is concerned. So, this is increasing, and this is a good news that almost about 16 plus or 16 more than 16% capability we have in terms of electricity generation from these two alternate energy sources, that is the solar and wind is concerned as far as the globe is concerned. So, that means here is the potential in terms of mitigating, in terms of generating this as a green energy, and that can be implemented or that can be triggered towards mitigating the climate change as far as the energy sector is concerned. So, in terms of the alternate energy sources and price drop. So, warming cannot be limited to well below 2 degrees centigrade. All of us are talking, the world is talking to arrest the temperature rise below 2 degrees centigrade, because beyond 2 degrees centigrade many more havocs will happen. but if human population or humanity wants and take all the adaptation mitigation measures to try, then perhaps it is possible to arrest the rate of temperature rise by 2 degrees centigrade in comparison to the pre-industrial era that we usually take for the duration or average duration of between 1850 to 1900. So, we need to arrest it by 2 degrees centigrade in energy systems also, carbon dioxide and other greenhouse gases emissions. So, limiting this will require substantial energy system changes. So, to achieve this or to arrest up to 2 degree centigrade temperature rise, what we need, the world need to act heavily on the alternate energy resources or in the energy system sector over next 20-25 years or by or next 25 to 30 years time period. And then this includes, what is that? It includes reduction, minimization or complete stop of the fossil fuel consumption. So, first thing, we need to reduce or almost do minimal consumption as far as fossil fuel is required, then are concerned. Second, we need to increase the production of low and zero carbon energy sector and increase the use of electricity and alternate energy carriers. So, battery technology we have to develop and we have to trap energy from other renewable energy sources which is more greener in nature. This will actually lead to achievement of the net zero or you say the net zero energy systems will share common characteristics, but the approach in every country will depend on national circumstances. So, this having said that it has potential, it needs to be done and we need to switch over to low carbon based or based energy system, but the reality is it depends on various nations, their mindset, their capabilities and the different circumstances on which they operate including the capability. So, but what has actually been seen that the prices have dropped rapidly over the last 5 years for several key energy system mitigation options, notably in terms of PVs or you say photovoltaic cell, wind power and batteries. This is a good news, because when we talk about adaptation of this low or zero carbon energy sources, the important or vital factor is the price or the cost. So, over last 5 years it has been seen that the cost or the price has been substantially dropped in terms of the solar photovoltaic cells or wind and the battery or the cost of the battery. So, if investment in coal and other fossil infrastructure continue, energy systems will be logged into higher emissions, making it harder. So, the point is a kind of warning here that we need to stop emission from the fossil fuel sectors. So, if we do not do, then perhaps it will cross the limit and we cannot arrest the temperature rise below 2 degrees centigrade. So, now coming to the transition. So, coming to the transition in terms of a high carbon energy system which currently exists to a low carbon energy system, this transition or the shift will lead a lot of investment pattern or shift in the investment pattern, so that new economic opportunity will come. So, what we mean say the multiple sectors has to be activated, so that this shift in terms of the investment pattern and creation of new jobs and the new economic opportunity has to come up. Then only this will be realized, the benefit of this or the larger adoption of this will be realized by the humanity or a larger population base. The climate change will affect many future local and national low carbon energy system. The impacts, however, are uncertain, particularly at regional scale. So, this is means as you mentioned, it varies in terms of the capability of circumstances between or from nation to nation. So, it is actually varies and lot of uncertainty also there in terms of a regional scale. So, let us see the climate change will alter the hydropower production, bioenergy and agricultural yields, thermal power plant efficiencies and demands from heating and cooling. Look at this. Because of climate change, these components of the energy sector will be affected. So, what are they? The hydropower, because the moment we realize that there is alteration in the precipitation pattern, then it will lead to alteration in terms of the supply of water as far as the hydropower generation or production is concerned. So, climate change is going to alter the hydropower production in that sense. Also in terms of the bioenergy, the moment we talk about land use and conversion of or change of land for other purposes instead of the what you say plant or the natural forest or the vegetation is getting cleared and getting converted to non-vegetational use. That means less land area is available for bioenergy related vegetation plantation or vegetation cropping. So, then because of the land use related changes which is induced by the climate change, the bioenergy sector will be affected. So, also the yield in terms of agriculture and the efficiency in terms of the thermal power plants, because we are talking about alteration pattern in terms of the heating or vice versa cooling, the pattern in terms of the diurnal and seasonal temperature is going to vary. So, that will affect the efficiency as far as the thermal power plants is concerned. So, if all the systems will be affected, then it will directly affect the energy infrastructure. So, electricity systems powered predominantly by renewables will be increasingly viable over the coming decades, but it will be challenging to supply the entire energy system with renewable energy. Yes, the way we are going in terms of R&D, in terms of the demonstration, in terms of implementation, protocol development and other sectors, particularly the economic financial sector coming into play, it is going to be a reality that electric systems will be renewable, will depend on the renewable sources, but there is a challenge that the entire energy systems to make renewable is the challenge. So, that is where the future generation or the coming days we are going to work and make it feasible. 100% renewable energy systems would likely need to include alternative fuels such as hydrogen and biofuels. Yes, we know that for sure. In our subsequent class, we will also discuss in terms of the what you say the transport. We will see that how the transport sector is going to depend on many other sectors, the energy coming from many other sectors including hydrogen and the biofuels, and also the heavy replacement in terms of the shipping and aviation sector, also the long distance heavy and large scale trucks. So, we will see it in the subsequent class. So, multiple energy supply options are available to reduce emissions over the next decade. So, we have to go for multiple energy supply options. So, whatever is coming from various alternate energy sources, green energy sources, wind, solar, hydrogen, biofuels, all the multiple options we have to take care, we have to integrate, we have to cumulatively use, so that we can nearly replace or we can nearly meet the entire energy requirement as far as the globe or the humanity is concerned. So, coming to the potential. So, you can see on the lower left hand side and upper right hand side, we have put two depictions as far as the irradiance in terms of the solar energy is concerned, or on the right hand side you have the wind power is concerned. So, the irradiance it is kilowatt hour per meter square per day. So, please see you have different gradations which is going from 1 to 8 in terms of watts per meter square, in terms of kilowatt hour per meter square per day. And if you focus, then you will see the maximum is towards the equator dominantly as Africa and the part of the Saharan island and Western Asia or Southwest Asia, whereas if you see on the northern part of the Australia and southern tip of again the Africa and also the west central portion of the South America, you can understand that the distribution of the mean global horizontal irradiance, we call it GHI, is the maxima. So, what does it mean? We have the availability of irradiance potential, this is the variation pattern, and if this is the availability, then this decides or this could well guide us in terms of putting our trapping equipments in order to trap the irradiance. Similarly, as far as the wind power is concerned, which is represented in terms of the power at 100 meter in terms of density watts per meter square, you can see a lot of wind power is available over the the Arctic areas on either ends and also the coastal area. Look the complementarity. So, the irradiance map is showing maximum in the tropics, whereas the wind power is showing maximum availability in terms in the Arctic or the polar regions and also along the coastal region. So, together it caters the need in totality. So, this is a good combination in terms of trapping the irradiance or solar energy and the wind energy as far as the global, as far as spatial distribution of the globe is concerned. So, a low carbon energy transition will shift investment pattern and create new opportunities. We discussed this, and moving on, some mitigation options can provide more immediate and cost effective emissions reductions than others, but a comprehensive approach will be required over next 10 years to limit the warming below 2 degree centigrade. So, what we discussed, we need a comprehensive multi-sectoral approach to bring the cost factor down and as quickly as possible, that means perhaps by end of this decade or so. So, if we achieve this, we are working in different fora which will be discussed towards the last part of our this whole course in the week during 9 to 12, where we will know that how the finance sector, the political sector, the diplomacy sector and all other sectors are acting together, governance sector to make it happen, and enhance integration across energy system sectors and across scales will lower costs and facilitate low carbon energy system transition. So, as we know, if we do this, this will support well the sustainable development goal objectives and other social objectives. Coming to the dimensions and indicators of implementing mitigation options in low carbon energy system. So, we have put it in 1, 2, 3, 4, 5, 6. The first one is physical, particularly geophysical. Second one is environmental or ecological. Third one is technological. Fourth is economic. Sixth is socio-cultural, and seventh is institutional. So, first is the geophysical. Are the required resources available in terms of geophysical? So, coming to the indicators to answer this matrix or this question, physical potential and physical constraints to be implemented, geophysical resources including geological storage capacity, availability of resources needed for implementation, land use claims on land where an option would be implemented. In terms of the environmental and ecological challenges, what are the wider environmental and ecological impacts of this particular option? So, the point is In terms of air pollution, yes, there could be increase or decrease in air pollutants such as methane and ammonia and fine dusts, toxic waste, ecotoxicity and eutrophication as we know. The water quality and quantity changes in amount and water availability for other uses, and coming to the most important point is the biodiversity change. So, changes in conserved primary forest or grasslands that affect biodiversity and thereby management to conserve and maintain land carbon stock. So, similarly, moving on to technological, can the required technology be upscaled soon? This is very important because we need to upscale whatever demo prototype we develop, we need to upscale by incorporating all other variations or constraints that coming from multi sectors or multiple factors or circumstances. So, simplicity is the option, technically simple to operate and maintain and integrate. So, one of the very viable option is make the technology as simple as possible, so that it can be adopted by many. If there is certain problem, it can be repaired, it can be maintained, and all those options will be open. Technology scalability, can the option be scaled to technically? We need to ask that there has to be scalability as far as the technology is concerned. Maturity and technology readiness. So, research and development, R&D and time needed to implement the options. The fourth one is in terms of economy. So, what economic conditions can support or inhibit the implementation of this option? So, perhaps the cost, particularly the cost in 2030 and in the long term investment cost has to be brought down, and employment effects and economic growth has to be there. So, we have to ensure that there are jobs or new jobs are created in this sector. So, the in terms of the socio-economic welfare. Coming to socio-cultural, what social conditions could support or inhibit acceptance, adoption and use of the options before 2030. So, we have the indicators. Effect on health and well-being we have to study, we need to understand public acceptance, the distributed effects in terms of equity and justice across the groups. Come to the sixth one, that is the institutional. So, what are the institutional conditions that could support or inhibit the implementation of the option? So, one is the acceptance at political sector, the capability in terms of institutional and governance sector, and also our readiness or capability as far as the legal and administrative framework is concerned. So, all these 6 sectors makes the matrix and the indicators that define these matrices. So, in this way we discuss about the various dimensions and indicators of implementing the mitigation options in low carbon energy system. So, we need to understand and we need to address them, and we need to make it possible and feasible, so that it will be taken up by a larger, it will reach to a larger mass. Now, coming to the various factors in terms of enabling factor and in terms of inhibiting factors as far as the deployment of mitigation options in energy system is concerned. So, the first one is solar, moving on wind, hydroelectric, nuclear, carbon dioxide options in terms of utilization and storage. So, we call it CCS, and the bioenergy, fossil fuel phase out, geothermal and energy storage for low carbon grids, demand side mitigation and the system integration. Moving on to the matrix, on the upper side you can see all these 6 different matrices that we just discussed in using the previous slide. So, geophysical, environmental and ecological, technological, economic, socio-cultural and also the institutional. So, let us talk about the first one, that is the geophysical, and on the in terms of the first energy source, that is the solar energy. So, look at this in terms of the physical potential as far as the solar energy is concerned, it is an enabler. It enables as far as the solar energy is concerned, the physical potential enables it, whereas the next one is the geophysical resources. Yes, it does enable, and the third one is in terms of land use. Land use also acts in both ways. It is also an enabler and also an inhibitor, because wherever possible it facilitates, but at places it also inhibits. So, because of the solar energy, at many places the land use is the land is inhibited for any other use. So, accordingly we can evaluate the whole matrix and the various what you say matrices, and with respect to all the different alternate energy sources. Moving on, we have the relevance of key climatic impact drivers for major categories of activities in the energy sector. Similarly, on the in terms of the energy sector, we have mentioned all these alternate energies, and in terms of the first column, coming on to energy in terms of their activity. Yes, there are activities in terms of resources damped and resources undamped and R&D. So, let us see in terms of the characteristics. We have hot and cold, wet and dry, wind, snow and ice, coastal, open access and others. So, these are the various climate related impacts as far as the alternate energy sources are concerned. So, look at the first one as we go with the hydropower. In terms of hydropower, come to the wet and dry, the second category as far as the climatic impact driver is concerned. So, in terms of the mean precipitation, we have mean precipitation, and the river flood we have a green cover. So, that means if it is that, then it will positively address this. So, we need more precipitation availability and flood situation both can be in a green. That means as far as the hydropower is concerned, it helps, or it takes care as far as the climate change mitigation is concerned. Coming to the next one is with respect to the aridity, hydrological drought and agricultural and ecological drought as far as the wet and dry is concerned, here in terms of the dry particularly. So, here it is shown the red mark. So, in terms of red mark as far as the resources are concerned, yes, hydropower will be negatively affected by climate change or by temperature rise. So, as far as the hydropower energy sector generation is concerned. Similarly, if you see the total matrix, most of the places it is red or orange or yellow, and very few places it is green. So, it means that there is relevance of the key of these key climate impact drivers for all these categories of activities in energy sector. So, if we do it, then perhaps we can negate, we can alter, we can reverse many of these climate induced changes and thereby contribute towards mitigation measures. Then coming to the net zero. As we discussed, this is a schematic diagram as far as the net zero emissions of from the energy system or the energy sector is concerned. So, net zero energy system will need to rely on alternate or alternative fuels, notably hydrogen or biofuels, in several sectors that are not amenable to electricity and otherwise hard to decarbonize. Useful carbon based fuels, for example, methane, petroleum, methanol, hydrogen, ammonia or alcohol, all these useful carbon based fuels, they can produce very less CO2 equivalent emissions without fossil fuel input. So, have a look at the interwoven and interlinked kind of system where we are talking about various essential energy services, and towards the lower side we have all the green energy, and we have places where the red is there. So, you can see the geological storage and all these options in terms of carbon, and also ammonia, methane and all other different energy services sector have been mentioned. So, this linkage and interlinkage will lead to achievement of the net zero target or the net zero emission target, both by the nation, by individual nation, and thereby the globe. So, we have taken help of this particular literature, again the working group 3 and the relevant chapter on energy to prepare these slides. Please refer to this to read or to learn more about this. So, in conclusion, what we mentioned in the concept, we covered this in terms of various alternate energy sources, the multiplicity of the system, and the challenge in terms of addressing the cost effectiveness. We also talked about the low carbon energy systems and various enablers or inhibitors that come on the way of deploying the mitigation options in this energy sector. And we also talked about the various relevances as far as the climate change is concerned. So, the climate impact drivers as far as the major categories of activities in this energy sector is concerned. And towards end, we discuss in terms of a broad schematic diagram which is interlinked, that it is possible to achieve, it needs to be achieved in terms of the net zero emission for the energy sector or for the energy system. Thank you very much, and look forward to discussing more with you.